We are adding more onto our knowledge of matrix algebra. We are going to learn how to multiply entire matrices. So the last thing we did was multiplying a matrix by a number, like one matrix by a constant, or multiplying a row matrix by a column matrix. Now we're going to multiply entire matrices. So remember what we did when we looked at how much it would cost for Arthur to drink all this coffee and all this tea on Monday, Tuesday, and Wednesday. We actually calculated each day separately. Like we calculated Monday by multiplying this row by this column, right? This row by this column. We got one number. We did the same thing for Tuesday. Got one number, €9. And we did the same thing for Wednesday. One row by one column. We were multiplying by the exact same column, €3 and €2 for the coffee and the tea, but the rows were different for each day, right? Now, I want to show you how to do all 3 days all at once. So, if we copy down this matrix and this one, we get this. So the words coffee, tea, the euro signs, they're gone, but we're still talking about the same things. So when we want to multiply matrices, there's one important thing. We need to look at size. Or order is what we called it as well, but it just basically describes the size. When describing the size of the matrix, we name the number of rows and then columns. So this is a 3-row by 2-column matrix, and this is a 2-row by 1-column matrix. Yeah. Now the important thing, when we want to multiply matrices, these inside numbers have to be the same. These have to be the same. Otherwise we'll run into trouble, right? We would do the first number in the row times the first number in the column, second number in the row times the second number in the column. What if there was like an extra column here, but there wasn't a number to multiply it with in the row? That would make no sense, right? So these two have to be equal. Otherwise there is no number to multiply the other number with. These outside ones don't match up. That's fine, right? Imagine this 3 is actually the number of days that we're calculating his coffee and tea intake over. We could do that for Thursday, Friday, Saturday, Sunday as well, right? 7 days. And we could still figure out how much he paid for all his coffee and tea. It does not matter that this number is bigger than this one. Nobody cares. And, you know, considering our coffee and tea situation, that makes a lot of sense. What these numbers do tell us, though, is that we're going to end up with a 3 by 1 matrix as an answer. So our answer is going to be a 3 times 1 matrix. So I can make room for that already. It's going to be 3 rows, and it's going to be, I could actually do these brackets like this. I do them like this, but it should actually be rounder. Who cares? Okay, so we've just decided, yes, we can multiply these because the inside ones are the same, inside numbers, size numbers, and we already know that it's going to be a 3 by 1 matrix. Now, how do we solve it? Let me show you. We need to keep track of where we are. That's why I made these little things. We're going to start with our first row, and we're going to multiply it by this column. This is actually just doing what we did for the Monday, remember? I'm going to take some shortcuts to save time. I hope that's okay. First number multiply by the first number here. 2 times 3 is 6. Plus 3 times 2 is also 6. So 6 plus 6 is 12. We write that up here. Now we move to the second row and still this column. 1 times 3 is 3. 3 times 2 is 6. 3 and 6 is 9. Next row. 1 times 3 is 3. 4 times 2 is 8. 3 and 8 is 11. And this is our answer. Okay, let's see if we can do that with a slightly bigger matrix. These are random numbers. Let's see if we can do it. Let's first decide if we can even multiply these. This has a size 3 by 3, right? This has a size 3 rows by 2 columns. The inside values are the same, so we can multiply them. These outside ones tell us it's going to have 3 rows and 2 columns. Great. First row. First column. Okay, this is going to give us our first number here. I actually think I need space down here. Let's do this. Let's just make more room. 1 times 1 is 1, plus 2 times 2 is 4, plus 3 times 3 is 9. Let's transfer it right away over here. This added together is 14, gives us this number. Then I want to do the one down here. 4 times 1 is 4. 0 times 2 is 0. 1 times 3 is 3. This added together is 7. We've now found our number here, second row, first column. Next, 2 times 1 is 2, plus 1 times 2 is 2, plus 2 times 3 is 6. These added together give 10, so that's our third row, first column. Yeah? Now we're moving over to the next column and starting with our first row again. We're now going to fill in, goodness, lost my pen. We're going to find the answers to our second column, the answer's second column, and we're going to start with row 1 again. So 1 times 3 is 3, 2 times 2 is 4 plus 4, 3 times 1 is 3 plus 3. This together is 10. It's our second column, first row. Second row, second column. 4 times 3 is 12. Plus 0 times 2 is 0. 1 times 1 is 1. These added up are 13. Next row, still on the second column. 2 times 3 is 6. 1 times 2 is 2. 2 times 1 is 2. These added up are 10. And we're done because we've moved through both our columns and we've moved through our rows twice, once for each column, right? And as you can see, these outside numbers tell us it's going to be a 3 by 2 answer, and that's what we got. All right.